Good afternoon, good evening, depending on when you're watching this. It's your boy again, Mr. Malachi, and I'm back with another video. And this one is on literal equations. So, what are literal equations? These are equations, we're going to get different formulas, right? You can think about the formula that Einstein came about, E equals to mc squared, the theory of relativity. You can think about PV equals to nRT formula. That is the formula for ideal gases. These different formulas that we get, we have this area formula, which is pi r squared. That is the area formula for a circle. And yeah, we get different formulas, and what we are doing in literal equations is that we are taking these formulas and we're manipulating them so that we can get a different variable as the subject of the formula. And what do I mean a different variable as the subject? Right now, if you're reading the top, it says energy is equal to mass times speed squared. That's what that formula is saying. But what if I wanted this to read mass instead? I wanted it to say mass is equal to the rest of it. That is what literal equation is. It's taking a formula, manipulating that formula, and getting it to look like the way you're trying to make it look. Which, whatever variable that you're trying to solve, let it be the one that is on the left hand side. So for example, this PV equals to nRT formula, I could get it to look like the R being the subject of the formula, where it reads R is equal to the rest of the equation. Or this one that says area is equal to pi r squared, I could get it to have the radius equal to the rest of the equation. So that's what we are doing on the literal equation. We're taking an equation that's already given, a formula or something like that, and we're making a specific variable the subject of the formula. I hope you get that. Let's jump right into the first example. Alrighty, let's have a look at example 1. In example 1, we're given the area of a rectangle, which is length times breadth, and what we are asked is to make B the subject of the formula. So what are we going to do in this case? All that we need to do is we need to do the inverse operation of what's happening to B right now. So if you identify there's our B there, and what is happening to it, it's being multiplied by an L. So what is the inverse operation of multiplication? It would be to divide on both sides. So I would divide by L there, and I would divide by L there, and so these would cancel, and so area divided by length is equal to my breadth, right? So I could leave it like this, but I always like putting it the way they wanted, which is writing it in terms of you reading it this side, which says B is equal to the area over the length. And I hope you're seeing what I'm doing in the last step. It's just like how we have x is equal to 2, but we can have 2 is equal to x. These are just the same thing but written different ways. So that's literally what I'm doing in the last step there. I'm just writing it with the B, the one that I'm looking for, the one that we're asked to make the subject, is equal to the rest of the equation. So that's how you go about solving question 1. So let's try example 2. So example 2, let's copy it down here on the left. In example 2, we're given that velocity is equal to u plus at. And what we are asked to do here is we are asked to make the acceleration the subject of the formula. So what do? First of all, we need to find where the acceleration is. There is the acceleration there. So what is happening to it? It's being multiplied by a t, but it's being added by a u. So what do I need to do? I need to do the inverse operation, take the u and take it to the other side, so that I isolate the V, the A. So if it goes to the other side, it looks like that. The sign changes, obviously. Then at this point, what do I need to do? I need to get rid of the guy that is multiplying the A. And the only way to get rid of it is to divide by t on both sides. These t's are going to cancel, and so v minus u over t is equal to a. And again, just to do that last step of me looking at it the way they wanted, which is v minus u over t. And there we go. There is my formula for acceleration. I hope this is making sense. Let's do a couple of more examples. In example 3, we're given the volume of a cylinder. That's a volume of a cylinder, which is pi r squared times height. What we're asked to do is to make r the subject, the radius. So what do I do first? I need to identify where my r is. What is happening to that r is being multiplied by pi and it's being multiplied by h. So I need to do the inverse of that. Divide by the pi and the h. Divide by the pi and the h. So these are going to cancel and these are going to cancel. So I end up with v divided by pi h is equal to r squared. Then now that we have it like this, we need just r by itself. Right now it's r squared. So the best way to get rid of a squared is to do the inverse of squaring, which is square rooting. So what do? I'm going to root this side and I'm going to root that side. Right? And if I root anything, in this case it does not count because r is always positive. But if in other cases, if you're square rooting something, you need to indicate that the positive or negative answer are possible answers there. But in this case, it does not matter. Let's just leave it as the positive one. So we have a pi h there is equal to r. And if you look at this the other way around, v divided by pi h is your final answer. And again, just to speak more about why if you square rooting, you need a positive and negative response. Because think to yourself, if you take a 3 and you square it, you get a positive 9. If you take a negative 3 and you square it, you get a positive 9 as well. So what is that telling me? It's telling me that actually if you square root a 9, the possible answers are a positive 3 and a negative 3. Both of those guys are equally correct. So that's what you would have put there, plus minus. But since this is a radius cannot be negative, so it would not make sense for us to put a negative there. It will always come out as a positive answer. So in this case, you wouldn't do it, but usually you would have to put the plus minus outside of the root. So let's look at another example, example 4. Alrighty, so for example 4, this is, we're asked to make x the subject. And this is an example that includes a little bit of factorization. And how do I know it's factorization? Because we have x in 2 terms there. So what I need to do is I need to bring all the terms of x in one side and take all the ones that don't have x to the other side. So the bx is going to come over, and if it comes over, it becomes a negative. The 2a is going to go over to the other side, and if it does that, it becomes a negative 2a. Then once I have it like this, then to isolate this x, to get this x to be by itself, the best way to do it is to take out the x as a common factor. So I take out an x like that, and inside of my bracket will be the 2, because the x times the 2 will give me back to the 2x. And again, it's a minus b, because the x times a minus b would give me back to this negative bx. So I got the guys inside of my brackets. It's equal to a negative ab minus a 2a. So now that I have that guy, I could just easily divide on both sides by the guy that's multiplying my x. So this bracket here, divide by it on both sides. So this would cancel with this guy. And so x is equal to a negative ab minus a 2a over a 2 minus a b. And this would be my final answer. And there we go. Very easy. This is how you apply, or well, you get your subject of the formula, but this one also included some factorization. Right? Let's look at another one that includes maybe some fractions. Alright, in this next example, we're given that p is equal to m squared minus x over 2. And we see a fraction there, so we're going to have to apply our rules of fractions. And our rules of fractions, by the way, we are asked to make x the subject. As I was saying, our rules of fractions is to always find the lowest common denominator. In this case, it's just the 2 because there's only one denominator. And once I have that denominator, I need to multiply everything with that denominator. So my p will be times by the LCD. The m squared will be times by LCD. The x over 2 will be times by the LCD. So that's what I do. Then I just expand these or multiply these and cross multiply. P times 2 is a 2p. M squared times 2 is a 2m squared. And these are going to cancel, leaving me with just a negative x. And now that I have it like that, I could just bring this x to this side so that it's a positive. Take the 2p to that side so that it's not with the x. So x would now be a positive, and it will be equal to a 2m squared minus a 2p. And there we go. This is our final answer. We have x as the subject. We are complete. So this was example number 5, which included some fractions. So let's look at another one that also includes fractions, but it also includes some factorization. Alright, so for this example, we notice that there's fractions, but our variable that we're looking for is in the denominator. So what we do, we still do the same thing we would do when we were working with fractions, is to find lowest common denominator. In this case, it would be the x. And to do the same thing, take that lowest common denominator and multiply it with every single thing. So it multiplies with the first fraction. It multiplies with the positive 1 times n times x, and then it needs to multiply with the m. So I'm showing this multiplication in different colors so that you can see that this guy right there is my LCD. So if it multiplies there, these just cancel, leaving me with just an n. 1 times an x is a 1x, and an m times an x is a mx. And we have something that looks like that. So now I need to drag the one that has the x to join the other one that has the x. Remember, that's what you do when we have two of the same variable that is present there. You bring them all into one side, and once you have them all in one side, the best thing to do right now is to take out a common factor. So I take out x as my common factor, and I'll get m minus 1. Then now in my last step is to divide both sides by the guy that is multiplying the x, and in this case it's that bracket there. And so technically n over m minus 1 is equal to an x, and so if I read it the other way around, x is equal to an n over m minus 1. And there we go. This is our final answer of x. So in this question, you would have noticed that this one included fractions, but not just fractions only, it also included factorization. So know how to work with a question that has both. and a question, the prior questions or the preceding questions, those ones had either the fraction part or the factorization part. So at this point, I think you're seeing how do we work with these. Let me give you one last example and then we're going to call it a day. Alright, so for this last example, we have A, which is accumulated, is equal to principal value, open bracket 1 plus I, all to the power of n. And we're asked to make I the subject of the formula. So what we're going to do first is we're going to divide on both sides by the P that is multiplying that bracket. So let's divide by P there, and we divide by P there. These are going to cancel, leaving me with just A over P is equal to 1 plus I to the power of n. So now we have an exponent of n. And I want to remind you that, remember, if we had an exponent of 2, to get rid of an exponent of 2, we would have to square root on both sides. Why? Because if you square root this 2 and these 2 are going to cancel each other. Right? So now we have an exponent of n. How do we get rid of that exponent of n? Is to take the nth root on both sides. So I'm taking a root of n there, and I'm taking a root of n there. So this nth root and this n are going to cancel. So this ends up being the nth root of A over P is equal to 1 plus I. So since the n is gone, you can also like get rid of those brackets there. They don't really do anything anymore. Alright, then now that we have it like this, you just take the 1 over and you'll get your final answer. So it's the nth root of A over P minus 1 is equal to an I. And there we go. That's your final answer. And we're done. So on that note, I hope this made sense to you. Practice, practice, practice. That's how you only get better at mathematics. So I'll see you in the next video. Bye.